G'day, science lovers. Today we are venturing out into the vast, dark expanse of our solar system. We are on a quest to uncover one of its most breathtaking and puzzling features. I am talking about planetary rings, those shimmering ethereal disks of ice and rock that encircle some of our celestial neighbors. When you picture a planet with rings, one name instantly springs to mind: Saturn. Its magnificent system is the undisputed supermodel of our cosmic neighborhood. It is a sight so iconic, so utterly beautiful, that it has captured the human imagination for centuries. These rings are not just solid hoops, like a hula hoop spun around a planet's waist. Instead, they are a colossal collection of countless individual particles. Saturn's rings, for instance, stretch out to a diameter of 282,000 kilometers, which is about 3/4 of the distance between the Earth and the Moon. Yet for all their immense width, they are astonishingly thin, with a typical thickness of just 10 meters. Our journey into the discovery of planetary rings begins not with a bang, but with a confused scribble in a notebook. In his sketches and letters, he described Saturn as a planet with ears, utterly baffled by what he was witnessing through his primitive lens. Sometimes the ears were prominent, and at other times they seemed to shrink and disappear entirely. This puzzle persisted for decades, vexing astronomers across Europe. That brilliant mind belonged to a Dutch astronomer named Christian Huygens. He saw not two companion bodies, but a single solid flat ring. As our technology improved, sending robotic explorers like the Voyager spacecraft on a grand tour of the outer solar system, we made a startling discovery. Saturn was not alone. It turned out that all the gas giants in our cosmic neighborhood have rings. Jupiter, Uranus, and Neptune each possess their own ring systems, but they are a world away from Saturn's bright, icy spectacle. They are so faint, dark, and flimsy that they are practically invisible from Earth. Their discovery was a huge surprise, completely changing our understanding of where and why rings form. The first and most obvious answer comes down to one simple word: size. The gas giants are just colossal. Their immense size gives them a massive gravitational pull way stronger than that of their smaller terrestrial cousins. The Roche limit is an invisible boundary, a sort of danger zone that surrounds every massive celestial body. If a celestial body like a moon or a passing comet crosses this line, it gets torn apart by the planet's immense gravity. The inner solar system, where Mercury, Venus, Earth, and Mars live, is a very different environment from the cold, dark depths where the gas giants reside. The inner region is much hotter, and it's constantly blasted by a powerful stream of particles and radiation from the sun. Saturn's rings are overwhelmingly made of bright, shiny water ice. This makes them incredibly reflective, like a freshly polished mirror. The rings of Jupiter, Uranus, and Neptune, however, are the complete opposite. They are made of dark, sooty material. Saturn's system is the most elaborate, a vast cosmic record grooved with thousands of features. These main rings are separated by prominent gaps, the most famous being the Cassini division. Saturn's many moons, both large and small, act as cosmic shepherds, gravitationally sculpting the ring material. The Prometheus and Pandora moons, for example, shepherd the narrow F ring, their gravitational tugs creating bizarre kinks, braids, and knots. The first is that a moon, or maybe a passing comet or asteroid, wanders too close to the planet, crosses the Roche limit, and is torn to shreds by tidal forces. The second theory is that the rings are leftover material from the planet's formation. The fact that they are still 99.9% pure water ice has led many scientists to a stunning conclusion: Saturn's rings must be young. This means that Saturn's rings may have formed around the time dinosaurs still roamed the Earth. We return to the inner solar system and face the question that has been lingering throughout our journey: why are we so bare? Imagine if Earth did have a glorious ring system made of pristine ice like Saturn's. The intense solar radiation would act like a celestial hairdryer, relentlessly heating the ice particles. This water vapor would be stripped away by the powerful solar wind. The red planet might actually be on its way to getting a ring, albeit a temporary one. Its tiny, lumpy moon, Phobos, is orbiting closer and closer to Mars. When it does, the planet's tidal forces will rip it to shreds, and its shattered remains will spread out to form a narrow, rocky ring. As we look out into the galaxy, we are discovering thousands of exoplanets orbiting other stars. This object, aptly nicknamed Super Saturn, appears to have a colossal ring system that is nearly 200 times larger than Saturn's. The particles in Saturn's rings orbit at mind-boggling speeds. Those in the innermost rings whip around the planet at about 80,000 kilometers per hour. The constant collisions between ice particles in Saturn's rings kick up a tenuous cloud of oxygen and water vapor. The study of these incredible structures is far from over. Many mysteries remain, keeping astronomers busy for decades to come. The biggest puzzle is still the true age of Saturn's rings. Planetary rings are not just objects of beauty. They are natural laboratories for understanding the fundamental processes that build planets and planetary systems. By analyzing their composition, we piece together the history of collisions and migrations that shaped our solar system. So the next time you see a beautiful image of Saturn, with its majestic rings glowing in the darkness, remember that you are looking at more than just a pretty picture. The enduring mystery of planetary rings continues to inspire us to look up, to ask questions, and to continue our exploration of the vast and wonderful universe we call home. Keep looking up.